Well, here are the answers to exam 1 questions, and I will not be doing a lot of talking because you can understand from what is written there. Number 1, upstream, the boat is going against the water, so it's going to be slowed down. And its velocity is 8 meters per second. Therefore, time is displacement by velocity. But when it goes downstream, the water carries it with it, so its velocity is going to be increased. And it's 12 meters per second. Now the time, again the same displacement, 83.3 seconds, and the total time is the sum of the two. Which is 208.3 seconds. In question 2, the initial velocity or initial speed is 2 meters per second. The final is 8 meters per second. The displacement is 12 meters, and you just have to find the time. So use the special equation. Displacement is average velocity multiplied by time. Although this question can be done in different ways, this is the easiest way to do it because the acceleration is not given. You get 2.4 seconds. Question 3, the helicopter descends 600 meters. The final velocity is 0. You got to find the acceleration and the initial velocity. Once again, use the equation. Displacement is average velocity multiplied by time. To calculate the initial velocity as 4 meters per second. And then E is equal to V naught plus AT could be rearranged to calculate the acceleration. You get it as negative 0.013 meters per second squared. The negative obviously shows that it is slowing down. In question 4, this can be easily done using a velocity time graph, because for the first t seconds it was accelerating and then it was cruising. So the area of the velocity time graph gives you displacement. So you have the area of the triangle added to the area of the rectangle, which is half base times height plus length times width. And here I'm multiplying by 2 on the right side, but I've forgotten to multiply on the left side by 2. I'll do that later. Now, in the first part of the motion as shown, we know that the final velocity, which is the maximum, is AT, and the acceleration is 1. So the final maximum is just t. So you can substitute that in place of t to give you, in place of this t, to give you Vm squared plus 120 Vm minus 2 Vm squared. Now I've multiplied the left hand side by 2 that I had forgotten before. So rearrange all this and get the quadratic equation. Upon solving the quadratic equation, we get the maximum velocity as 30 meters per second. In question 5, the rock is thrown from a height of 4 meter and the window is 20 meter above the ground. So the vertical displacement is 16 meter and the velocity has to be resolved into horizontal component 30 cos 40 and the vertical 30 sine 40. Now, considering only the vertical quantities, the vertical displacement is 16 meter and the initial vertical velocity is 30 sine 40, which is 19.3 meter per second. The acceleration is negative 9.8 meter per second squared because it's first going against gravity. You can find the time using y is v naught t plus 1/2 at squared. Substitute and rearrange. Once again, you get a quadratic equation. And on solving this quadratic equation, you get 1.19 second. Now, the horizontal displacement is always given by the constant horizontal velocity into time. So that's an equation that's always used when the velocity is a constant. So it's 30 cos 40 multiplied by the time that we got, which gives us 27.34 meters. In number 6, dog runs from A to B and then halfway back to C. Average speed is total distance by total time, so you got to add up AB plus BC, which will give 150, and then take 6.4 second and 1/3 of 6.4, which is 2.13. So you get 150 divided by the total time, which gives 17.58 meter per second is the average speed. But when you calculate the average velocity, you take only the displacement, which is AC, in that direction from A to C. Now AC is only 50 meter, but the time taken would be the total time, the same as before. So when you divide 50 by the total time, you get 5.86 meter per second as the average velocity. In question 7, you had to apply a fundamental knowledge of calculus. What you've given is the displacement vector or the position vector, and so to find the velocity you have to take the first differential with respect to time. So velocity is d by dt of position. So when you differentiate, remember you're not integrating, you differentiate that, this is what you get. This j quantity does not have t in it, and so it's absent. And when t is 3 seconds, in that you get the velocity. Now to get the acceleration, you got to differentiate this with respect to time one more time. And only the k quantity has time in it, and when you differentiate that, you get negative 2k, which is a constant. And that means at 3 seconds or at any time, the acceleration is just going to be negative 2k. In question 8, the word horizontal is very important, and since it's horizontally fired, its initial vertical velocity is 0. And the vertical displacement is 10 centimeters, which is 0.1 meter. Acceleration is 9.8 meter per second squared. Because it's going down, it's speeding up, and you can find the time taken using y is vt plus 1/2 at squared. And The first term becomes 0, of course. And you get 4.9 t squared, and on solving that you get the time as 0.14 second. Now again, the horizontal displacement is velocity multiplied by time. It's constant, so you can find that horizontal velocity just by dividing the displacement with time. A 0.1 kilometer is 100 meter. 100 divided by 0.14 gives 700 meter per second. In question 9, for the minimum time, the boat has to move at right angles, or begin moving at right angles rather. And so time is just the vertical displacement divided by the vertical velocity. So 1.5 kilometer divided by 12 kilometer per hour, so you get 0.125 hour, which is 7.5 minutes. In number 10, there are two cases. Case 1, the diver is a freely falling object. Case 1. And then case 2, the person hits the water and stops after some time. So from case 1, initial velocity is 0 because the diver just jumps off, and is 9.8. Displacement is 10 meter, and you can find the final velocity of case 1. Now this becomes the initial velocity of case 2, because that's the velocity with which the person hits the water. So that's the initial velocity of case 2. And the final velocity is of course 0. Acceleration we have to find. It's not a freely falling object anymore. Time is 2 seconds, so use the equation to find the acceleration. In fact, you get negative 7 meter per second squared, and so the net force, again the net force is mass times acceleration, which is negative 490 Newton. Now the negative shows that this net force is upwards. Now yet remember that the weight of the person acts downwards, mg. Net force is upwards, and therefore the force applied by water on the person, FPW, force applied on the person by the water, should be bigger and upwards. And the net force is the sum of the two. Do not take a negative here. Unknown quantities are always taken as positive in math. So when you rearrange, you get negative 1176 Newton. And again, the negative sign shows that the force applied by the water is 1176 newtons upwards, and it counteracts and goes over and above the weight of the person by 490 Newton. Number 10, straightforward question. Again, the airplane is flying horizontally, so its initial vertical velocity is 0. This has been stressed time and time again. Is 9.8 meter per second squared, and the vertical displacement is 120 meter. You can find the time, which is what you have to find in that question. Straightforward. Use the equation and substitute to find time. The first term simply vanishes because the initial velocity is 0, so you get the time as 4.95 seconds. In the last question, the object B and object A. All right. The force on A by B is FAB, force on A by B, And force on B by A is the reaction of that force. That's why it's in the opposite direction. And the unknown force, we do not know in what direction, just take it as Fx. Now to find the force, net force on A, or rather FAB, you get as 20 times its acceleration as 80 Newton. That is the net force on A. Now the net force on B is the sum of, again, don't take a negative because an unknown quantity is always taken as positive. So Fx is unknown, we just drew it in that direction, we do not know. So Fx plus FBA, net force is 40 times 3. And therefore Fx from that equation is Fb minus FBA. So 120 minus. So remember that FAB was 80 and FBA is negative 80 because it's the reaction of the other force. That's why it's negative 80. So you get 200 Newton towards the east, and that means the assumed direction that we took was correct, and it's towards the east. Thank you.